information from the graph of a function. Okay, so the first piece of information is the domain and range. And the way that that works is, let's say that we have a function that does, I don't know, just for an example, let's say I have a function that does something like that, okay? Okay, and then for the domain is going to be the set of x values. And you can kind of tell, okay, where does it start, where does it end? And that's going to be the domain. Now, sometimes this can go on forever, so you kind of have an idea that that's going to be the case. And you can only see a finite part of the graph, so you got to keep that in mind. And then the range is going to be the set of y values, so like the highest point and the lowest point in the graph, and that's going to be the range. So from there to there, and then the domain from there to there. So that's kind of how you can look at a graph and kind of figure out what the domain or range is. Again, sometimes, you know, the graph might, this might just keep going on up forever, in which case the range would go from this point up to infinity. Or this might go down forever, and so then, you know, likewise. You can also solve inequalities. Okay, so that's another thing you can do with a graph. So let's say we had a graph like, so like let's say, so you're looking for, let's say, if this for an example, let's say we're looking for something like this. We're trying to solve f of x is greater than or equal to g of x. Okay, so what you could do is graph the difference between those two. And maybe form a new function, which would be the difference between those two. Graph that function, and let's say it looks like that. And then your solution would be everything right here. Okay, if this was instead, if this was f of x equals g of x, then the solution would be these 2 points. Okay, now what I mean by this, okay, I'm about to clarify something. What I mean by this is it's not this part, but actually it would be these values here. So from negative infinity up to here, and then this would be from this point to positive infinity. And then if you had f of x less than g of x, that would be this part in here. So you look where the function's below, so less than would be below. If you set it up this way, below the x-axis, it would be like that. You could also graph both of these functions and kind of look and see where they intersect and which one's higher. The one that's higher is greater than, the one that's lower is less than. And where they intersect, that's where they're equal. Increasing and decreasing, you can figure that out from the graph. And now this is as x. So increasing is as you go from left to right. Okay, so you're going this way. As you're going from left to right, what happens? If it goes up, if the graph goes up, so like right here, for example, as you're going this way, as you're going that way, the graph's going up, so that's increasing. But then from here on over, it's going down, so that's decreasing as you go this way. Okay. Or this is also known as x values increase. Okay, so as you go from left to right, x values are increasing. Okay, local maximums or minimum values. That's another aspect of the graph, and that would be, so maximum values would be like this, for example. This would actually be the value, and it occurs at that point. So whatever y value that is, it occurs at that point. This is a local maximum because it's higher than all the surrounding points. Okay, and then local minimum values. Examples would be right here, which would be this value here, and this would be the point, the value, and it occurs at that point. And this would be the value, and it occurs at that point. Whoa, this is just like eraser, this yellow one. Okay. Let's go into the homework then. So number one, the function of f graph below is defined by a polynomial expression of degree 4. Okay, so to find a function value f of a from the graph of f, we find the height of the graph above the x-axis at x equals a. Okay, so to find a, so if a is 3, for example, we're going to see f of 3. So here we have 3. Okay, so here we have 3. Here's 3. So we look and see the point on the graph, and this is a 4, right? So that means that's 4. F of 1. Okay, so let's look at f of 1. So f of 1. So here we go to 1, and we see that it intersects there, and that's 1. That's 1. Okay, the net change in f between 1 and 3, as you go from 1 to 3, the net change is going to be f of 3 minus f of 1, which is going to be 4 minus 1, so that's going to be 3. Okay, so 4 minus 1 is 3. So f of 3 minus f of 1 is 4 minus 1, so this 4 minus the 1. So net change going from a to b is f of b minus f of a. Okay, let's take a look at number 2. The function, okay, so you have the graph right there. The domain of the function is all the x values of the points on the graph, and the range is the corresponding y values. Okay, from the graph, we see that the domain, now here, what I talked about earlier on the first page was, this is a polynomial expression, so it actually keeps on going, and it keeps on going down, like that. But it goes all the way to the left and right too. So the domain is actually negative infinity to infinity. Okay, now the range, okay, this is the highest point on the graph right here, which is 7. That's the highest point on the graph. Okay, but like I said, these go down forever and ever. So that means that the range is actually negative infinity, because it goes down forever, all the way up to 7, including 7, because it attains 7 right here at this value 2. It attains 7, okay? So let's look at number 3. Here we have the same graph again. Okay, part A, if f is increasing on an interval, then the y values of the points on the graph increase as the x values increase. Or actually, that's not an option. Rise. Okay, the y values rise as the x values increase. And it's increasing. Okay, so increasing. So as you're going this way, okay, you got to go as you go from left to right. What's happening? Well, this is going up. So that is increasing all the way from negative infinity to 2. Okay, so you're going to go negative infinity to 2. Okay, now you can include this point, or you can choose to include the point or not to include the point. So let's show you can include the point. Now from 2 to this next point, which is 4, it's decreasing, it's not increasing. But from 4 to 5, it's increasing as you're going from left to right, as x values are increasing. So 4 to 5. So I'm going to go union 4 to 5. Now you can get this by looking at, you can get this union sign by looking at the set tools, or you can type in union. Okay. So yeah, to get that, just to make a note here, you can type in union in Webassign, and then as soon as you hit the end, boom, it will change to that. Okay. Part B. F is decreasing on intervals and the y values fall as the x values increase. So in the graph, we see that it's decreasing on the interval. So from here to here, it's decreasing. So that's 2 to 4. Again, you can use parentheses if you want, but then it's also decreasing from 5 to infinity. So it's decreasing all this. Okay, great. So that's those problems there, number 3. And again, if you have any questions, just ask. Number 4, same graph of the same function. A function value f of a is a local maximum value if f of a is the largest value. Okay, so this is largest of f on some open interval containing a. In the graph f, we see that there are 2 local maximum values of f. So we have this one right here, and these 2 points correspond to local maximums. This one is 7. So that's one local maximum is 7. It occurs when x is 2. Okay, so the local maximum is 7. It occurs when x is 2. The other local maximum is, this is 6. And it occurs when x is 2, 3, 4, 5. Okay, so 7, 6, 5. Then we have local minimum values if it is the smallest value of f on some open interval containing a. From the graph, we see that there is one local minimum, so that's the local minimum. And that's going to be 2. It occurs when x is 4. Okay, so the local minimum would be the y value. This is the local maximums or y values. And where it happens is an x value. Okay, number 5. Here we have 2 graphs. We have f and we have g. And so the first question is, which is larger, f or g? Okay, so f of 6 or g of 6. So if we go 1, 2, 3, 6. So here's 6 right here, and we're trying to determine which value is larger. Well, this is higher than that. So g of 6 is higher than f of 6. That means g of 6 is larger. Okay, and then f of 4 or g of 4. So here's 4. F of 4 is higher. F of 4 is up here, g of 4 is down there. So f of 4 is larger. Okay, and then part C says, which values are they equal? Okay, they're going to be equal when they intersect. And so it's going to be there, there, and there. but we want the x values from when that happens. So that's 2, 5, and 7. Okay, find the values of x for which f of x is less than or equal to g of x. Okay, so that will be where the graph of f is lower. So where the blue one is lower will be right there. And the blue one's higher there. The blue one's lower there. Just in those two places. So from 1 to 2. And from 5 to 7. So just right here. And including the endpoints because it's less than or equal to. So the equal to part means you're going to include the endpoints and you're going to have these square brackets instead of round brackets, like this second one. That's still the same intervals, but they're not including the endpoints. But we're going to include the endpoints. Okay, and then number E, where f of x is greater than g of x. So you're looking where this is above, which is going to be right here. And then this is greater than, so you're not including the endpoints. Oh, wait, it's all the way to there. Oops. And then f is also greater over here. Okay, so that's going to be from 2 to 5. And then from 7 to 8, but not including the, well, you're including the 8. 8 is, you do include the 8, I'm sorry. Because at 8, f is up here, and it's actually greater than g. So the rest of these points are intersections. 2, 5, and 7 are where they intersect, though. So they won't be included. Okay. So we move along to the next problem, number 6. Here we have x squared minus 9, and sketch a graph. So I could do this on GeoGebra or something, or you could do it on GeoGebra. But I will say that this one right here is, we'll talk about this later. So I may as well just tell you right now that if you take the graph of, so we know that y equals x squared is a parabola that opens up like this, right? Now, if you tack a minus 9 on the end, this minus 9 will shift it down by 9. Okay, so instead of being there, the parabola is going to be shifted down by 9 values. Okay, so it'll be shifted down to there. So the vertex will be there. So it's one of these two. But then this condition right here says that you have to stay between -4 and 4. Okay, so it's going to be this graph right here, as opposed to that one where this one just goes outside the -4 to 4. Okay, so it'll be that one. Okay, and then use the graph to find the domain and range of f. Okay, so now the domain, again, is a set of x values, and you can see from the graph that it starts here and ends there, and so it goes from -4 to 4. You can also get that from here, by the way. And then the range, you can see this low point is there, and then we have this high point right there. The low point is -9. But the high point is when, as you can tell, the high point is when x is either 4 or -4. So if you take f of 4, you get 7. So the high point is 7. So -9 to 7. Okay, number 7. Solve the given equation or inequality graphically. Okay, so what we're going to do, what I explained, I talked a little bit about this on the first page, is you have some function f of x equals g of x. Now we could graph y equals x squared, and we could graph y equals 72 minus x, and then see where they intersect each other. Or you could bring everything to the left side of this equation. So that's x squared plus x minus 72. That's bringing everything to this side. Okay, so what I'm going to do is I'm going to go to GeoGebra and I'm going to graph this, okay? And we want to know where this is equal to 0. It's going to be, when it's equal to 0, it's going to be the x-intercepts is what it's going to be. Okay, so let's go to GeoGebra. Okay, so I have GeoGebra there. So I'll start the calculator, and I'm going to input the function that I told you guys. So x squared plus x minus 72. Okay, so suddenly everything disappeared, but it's actually what happened is it just moved outside of the range. So if I zoom out, then I can see. This is order 2, so it's going to be a parabola, okay? And this is kind of what it looks like. Now I can just click those points and see what they are. So it intersects at -9. That means that this is 0 when x is -9, and it's also 0 when x is 8. Okay, so -9 and 8, those are going to be my answers. Okay. Okay, so x equals -9 and 8. That's from the graph. Okay, now this next question is really the same function, the same two functions, but again, we can take this over to the left-hand side of the equation. So now it's asking, where is this less than or equal to 0? Okay, where is this? And this would be below the x-axis. Okay, so what values of x? For what values of x is the graph going to be below the x-axis? And so if we go back over to the graph, we can see that it's below the x-axis all the way from here to here. Okay, because it's below, and it comes back up, it's still below. Okay, so from -9 to 8 is the answer to that one. Okay, so that's going to be from -9 to 8, including -9 and including 8. Okay, now if it asked for above, or if it had asked for this one right here, greater than 0, then it would be where is it above? And the answer would be from -infinity to -9, union from 8 to infinity. Okay, but it didn't ask for that, so don't worry about that. That would be where the graph was above. Okay. Number 8. Use the graph of f to estimate the following. Okay, so the domain. Okay, so again, the domain is a set of x values, and it starts right there, and it ends over here. Okay, so the domain is everything in between, and that looks like 1, 2, 3, 4, -5, and that looks like 4. Okay, so -5 to 4, including the endpoints. Okay, and then the range, that's a set of y values, and so you look at the lowest point on the graph right here. That's the lowest point. This is the highest point. This is -5, that's 4. So this is really weird because the domain and the range are the same. Well, sort of the same, but not really. Okay, so part B, the intervals on which f is increasing and on which f is decreasing. Okay, so increasing. Okay, so as you go from here to here, it's decreasing. As you go from there to there, it's increasing though. Here to there, it's decreasing. There to there, it's increasing. It's going up. So it's increasing from here to here. Okay, now, like I said before, you can either include the endpoints or not include the endpoints. It looks like a 3 there. Okay, and then last one would be decreasing. So where is it decreasing? Well, from here to here, it's decreasing. So that's from -5 to -1. You can even choose to not include the -5 and you'd be okay, I think. That's decreasing there to there, all that. Increasing there, then it's decreasing from 0 to 1. And then lastly, it's decreasing from 3 to 4. Oh, it decreased a lot. That's a comma. Okay, so that's number 8. Number 9. Okay, so here it says graph this and then use the graph to estimate the following. Okay, so x cubed plus 3x squared minus 4x minus 12. So I'm going to go ahead and graph it using GeoGebra. That was x cubed plus 3x squared minus 4x minus 12. Okay, so here's the graph. It comes up like this, and then it goes down, and it comes back up like that. Okay, now we can go back to the graphs and try to figure out which one that is. So remember, it came up. We're looking for something that comes up. So the GeoGebra map, the GeoGebra graph was something like this. It came up, and then went back down, and then went up like that, right? Like that. And then of course these are just going to keep on going forever. So that definitely isn't it, and that's not it, and that's not it. This one actually is it. Although the GeoGebra was kind of really sharp turns here, but this is like more spread out, and that's because they've redone the scale. So this is actually 2 right here. This distance from there to there is about 2, but this distance here from here to here is 10. So they've messed with the scales of the x and y axis relative to each other. So anyways, let's answer the questions here. So the domain and the range. So the domain, that's everything. And the range, okay, so this keeps on going down forever and ever, and that keeps going up forever and ever. So that's also going to be negative infinity to infinity. Again, to get infinity, you can type the word infinity, and then as soon as you hit the y on the end, it'll change to an infinity sign. Or you can look for it in the symbols. Okay, part C says the state approximately the intervals on which f is increasing and which f is decreasing. Okay, so increasing is going to be this interval here, and also this interval here, from there to infinity. And then that's going to be increasing. And then decreasing will be this interval from here to here. Okay, now you can't really see it from this graph, so we'll have to go back to GeoGebra and try to get some estimates for the numbers here. Okay, so the nice thing about GeoGebra is that it will actually give you these high points. It'll give you the local minimum, maximum, local minimum. Okay, the local maximum here is 1.12845. It happens when x is approximately negative 2.5275. Okay, now the problem said find it accurate to 2 decimal places, and we're talking the x value. Okay, so as you go from negative infinity all the way up to this value of x, which is negative 2.53 approximately, the graph's increasing. Okay, so the first interval from negative infinity up to negative 2.53. Okay, then here, then from there to from negative 2.53 whatever to here, which is 0.53, it's decreasing. But then from 5.53 to infinity, it's increasing. So from here on up to infinity, the graph is increasing. The graph is rising. Okay, so unfortunately we can't like have see both of those at the same time, but here's what it is. Okay, so it's increasing from negative infinity all the way up to negative 2.53. And then it goes down from negative 2.53 to 0.53, it's going down, but then from 0.53 to infinity, it's increasing again. Okay, and negative 2.53. In between, it was decreasing that little bit. Okay, let's go on to the next exercise, number 10. The graph function is given. Use the graph to estimate the following. All local maximum and minimum values. So local maximum, there's 2 local maximums. They're right there and there. Those are the high points in the graph. This one, this is the higher one, but it's also got the smaller x value. So the x value is negative 2. Okay. Here the x value is 3. The y value is here is 2. This is 5. So this has to be 10, right? And this is 5. Okay, so that means that the smaller, so there's 2 x values where you have local maximums. One is negative 2, the other is 3. And then they want the ordered pair of points this time. So negative 2, comma 10, and then this one is 3, comma 5. Okay, those are the wait. No, I messed up. Whoa. Hold on a second. I messed up on the x values. This is 5, which means this is 10, and that's 15, which means that this is negative 10. Okay, so that's negative 10, comma 10. This is 15, comma 5. And then we have one local minimum, which is right here. And that happens when x is 0, and then it's negative 5. Okay, great. So that means it's increasing on this interval here from negative infinity all the way up to negative 10. And from 0 to 15. And then it's decreasing from here to here, which is negative 10 to 0. And also from 15 on up to infinity is decreasing. Okay, so that's number 10. Number 11. Okay, so here we're supposed to use a graphing calculator. So x to the 4th minus 9x cubed minus 19x squared. So we're looking for local maximums and minimums. Okay, so let's go ahead and go to GeoGebra. We will, so come over here. I'm just going to erase all this. And it's x to the 4th minus 9x cubed minus 19x squared. Hit enter and it erases the old one. Okay, so it's order 4. So that means that, and it's x to the 4th. That means as you go to the left, it's going to go off to infinity. And as you go to the right, it's also going to go off to infinity. Okay, so it actually, so it comes, as you come in from left to right, it's coming down here. And this low point is negative, okay, let's see, round to 2 decimal places. So this is negative 1 point, okay, so we rounded this 5 up. This 5 makes you round the 9 up to a 10. So it's negative 1.2, comma, negative 9.73. That's a local minimum. This is a local maximum, which happens at negative 1 point. No, that's a root. Hold on. That's not a local maximum. Okay, so 0, 0 is a local maximum. Actually, this is the only local maximum. Okay, so 0, 0 is the local maximum. Okay, 0, 0 is a local maximum. This point is local minimum. We already discussed that one. Now, now there's another local minimum, which is this graph. So you just got to scroll out. Come on, man. Yeah, scroll out until you find the bottom of the graph. I can kind of see it right there. And then click there. Oh, this is painful. Okay, scroll in. This is the bottom of the graph. It's not letting me click there. Click there now. Okay, there we go. There we go. So now this one, this is local minimum. 7.95 and negative 1728.43 is local minimum. Okay, so let's see, what's the overall shape of the graph? Whoa. is it comes down, local minimum, then goes up, and then goes down, local minimum. That's local maximum, and it goes up from there on, from then on out. Okay, let's go back in and put the answers in. Okay, so there was only one local maximum, and that was 0, 0, approximately. The local minimum was, now the first, local minimum on the left was negative 1.2, comma, negative 9.73. Okay, and then the other one was, I guess we should put it over here, 7.95 and negative 1728.43. Okay, that was the other local minimum. Okay, so the graph kind of went like this. It came down, it hit this bottom point, and then came up, and then it went down, but it went down quite a long ways, and then it went up from then on out. Okay, and so we'll say that's 1, that's 2, that's 3. 1 was this one. 2, or this point, this 2 point was this one, and the 3 point down here was this one. That's kind of a rough sketch, but I mean, this went down a lot further than what I'm drawing at right here. Okay, so increasing would have been from 1 to 2. First of all, from 1 to 2. So that would have been from here to here, which gives negative 1.2 to 0. That's increasing. And then it's increasing from 3 on up to infinity, right? So this one, which is 7.95 to infinity. Okay, decreasing. That would have been from negative infinity up to the first point, which is negative infinity to negative 1.2. And then it's decreasing there. It's also decreasing here from 2 to 3, from the second point to the third point. So from here to here, so 0 to 7.95.